Okay, today we are going to be doing or we'll be talking about our trigonometric identities. That is more of a grade. Is it a grade 11? Yeah, it's a grade 11 topic. So I'm just going to say it's grade 11 trigonometric identities. Please forgive me, guys. I'm using like my phone and my exercise book. I don't have this advanced technology thing to use my phone in. Okay, so when talking about trigonometric identities, I know most people do have an idea of what we are talking about in this case, but in most cases, people tend to not understand what is it that we really are like trying to explain based on trigonometric identities. Let's say, for example, in general life, when we are talking about things that are identical to one another, like removing the trigonometry parts, just speaking about things that are identical to one another. When I'm talking about two things that are identical to one another, I may be talking about like something that is exactly the same or maybe identical twins, anything like that, just as an example. So mathematically, let's say for example, I'll just like make an example. If I say I have x plus 2 is equals to 5, just an example, I cannot call this one an identity. Why? Because this can, if I am saying that this is an identity, then I am saying that for every value of x that I can put here, I am going to get the value 5, which is going to be equals to the right hand side of this. So if the left hand side of this equation is not equals to the right hand side for every value of x that I'm substituting here, then therefore this is not an identity. This can only be an identity, or it's only true when I substitute x is equals to 3 on this. If I put 3 here, then it's going to be 3 plus 2, which is still going to give me a 5. Then that is an identity. So which means it only applies for one value. But if I say, for example, let me just use an example of a difference of two squares. Let me just say this is going to be x squared minus 1 is equals to, this can be x minus 1 multiplied by x plus 1. Using the difference of two squares, I can call this an identity. Why? Because for every value of x that I can substitute on the left hand side of this equation, whatever number that I'm going to get here, I can also substitute the same value on the right hand side of this equation and still get the same number that I got on this side. You can prove it on your side. You can put 1 here. If you put 1, see what are you going to get here. Take the same one, substitute it here, and see if you are not getting the same value here. You can also take, you can maybe put 7, 1 million, whatever value that you feel like. But whatever the value that you put here, you should put it on this side. So if you are still getting the same answer, which means that is an identity. That is what we mean about identities. So most of you, you will be seeing questions in your grade 11, even in your grade 12 level, where they are asking you to prove an identity. So they'll be giving you a long calculation just to prove it that this is equals to 1. Then most of you will be running away. But that is, I would just say, it is the easiest part of mathematics that we have from grade 11 and grade 12. Given you have a good basic mathematics. I always say this to my learners that for one to understand identities, you should first have the basics. The basics that you are supposed to have in mathematics is the fraction first. When I'm talking about fractions, you should be able to do addition of fractions. You should also be able to do subtraction of fractions and also do the multiplication of fractions. Without this kind of knowledge, you are likely not to be able to deal with the most trigonometric problems. Then number two, there are just some facts, because before we even start with proving identities, we have to first go and speak about the ones that are very normal, the very normal trigonometric identities. Even someone who never did maths or who got 5% in Facebook, they know what is sine squared x plus cos squared x, that it is equals to 1. But if you can ask them to prove how did you come about finding the one, they are not even sure. They're not even sure. They don't know what is happening. But everyone knows that. And also, some of the mathematics students, they still cannot apply that rule when it's needed. So I'm just going to start by maybe proving the most general, or should I say, yes, it's the most general identities that we have in mathematics. So the first one, we have tan theta is equals to sine theta over cos theta. You guys have seen this before. It's just that you didn't know how did it come about. And also there is this other one, which is sine squared theta plus cos squared theta is equals to 1. Okay. Firstly, let's say, for example, you are given a cast diagram like this, and this is your 0, this is your 90, your 180, your 270, and this is your 360. It's a full cycle. And you are given a point in your first quadrant, and we are going to call this point, it's your OP, with P having the coordinates X and Y. So then we are told that this angle here is your angle theta, for example. And I'm asking you to find me the sine theta of this. Automatically, you know that this is your opposite side, so it's going to be your Y. This is your hypotenuse side, it's going to be your R, and this one is going to be your X, which is your adjacent side. Adjacent means next to. When I'm saying this side is adjacent, I'm saying it is next to this angle. Everything that you are talking about, the soccer tower, it is opposite. Opposite to what? To this angle. You are referencing to this angle, to the theta angle. So this side is opposite to this side. Adjacent to what? It's next to. Adjacent means next to, because some people, not really that they don't understand what does the adjacent mean. It's the language. If you are Zulu, I can just say into eseceleni kwe. So iyiphi nakuzi side eliseceleni kwale angle, this is the one. So that is your adjacent side. Then opposite elibhekene nalelo side, of which is this one. Then you have your longest side, of which is your hypotenuse side in this case. And then you are asked to find the sine theta of this one. So sine theta, we said using the SOHCAHTOA method. This is the basic. Using the SOHCAHTOA method, you will say sine theta is equal to opposite over hypotenuse. What is your opposite in this case? Is your Y. What is your hypotenuse? Is your R. Then I'm asking you to find your cos theta for me. What is your what is your cos theta? It's car, so it's adjacent over hypotenuse. What is your adjacent? Your adjacent is X. What is your hypotenuse? Your hypotenuse is what? Is R, like this. Then every time, if now I want to prove this one, I'm first going to take this, what I'm going to take, of which is, so I'm required to prove, so I'm going to say RTP, which means required to prove anyway. So RTP, this is going to be equals to tan theta is equals to sine theta over cos theta. So I am required to prove that tan theta is equals to sine theta over cos theta. How do I go about proving that? Firstly, I have to first take the one side, the side that I feel like is the most complicated side than the other. That is how you choose the side. You first take the side that you think it's the most complicated than the other. For me, I'm going to take the right hand side in this case. So I do first write that I'm taking my right hand side, which means I have to rewrite my right hand side. So my right hand side in this case is sine theta over cos theta. In every trigonometric identity, when we are proving, these are the steps. You first write what you are required to prove. Then after writing what you are required to prove, rewrite the side that you are choosing, that you are going to break down up until you prove that it is equals to the other side. So in this case, I'm going to prove my right hand side that it is equals to my left hand side. Remember, we said TOA. TOA means what in this case? TOA means opposite over adjacent. What is your opposite in this case? Your opposite is your y, so which means tan theta is equals to y over x. Opposite over adjacent. Opposite over adjacent, that is y over x. Okay, so now, then, I've already have sine theta, but remember we said sine theta is equals to y over r. That is what you said. So which means where there is sine theta, I can substitute it with what? With y over r. So I'm going to substitute it by y over r, over, of which is this over. Then where there is cos theta, I can be able to substitute it with what? With x over r. So it's going to be x over r, like this. But in mathematics, mathematics doesn't agree with us to have this over. Now we are having 3 divisions like this. You cannot do that in mathematics. So what do we do in this case? So what we do in this case is we have to take this, take it to the side, which means a division is going to change to multiplication. If it changes to multiplication, then we flip. The denominator becomes the numerator becomes the numerator. So which means you are going to have y over r, still, of which is this one on the top. Then we take our denominator right now. What was the numerator changes to be a denominator. What was the denominator changes to be the numerator. So we are going to have what? Y over x, like this. So now, I usually say it, like in terms of multiplication of fractions, these are 2 fractions multiplying one another. It's more like you're saying this multiplied by this multiplied by this. Then you now see that some of these things, since they are multiplying one another, they can cancel. But then in this case, you're just going to cancel r with r. You are left with what? Y over x. But if you remember, at first we said tan is equals to y over x. Therefore, we have already proven that. Y over x is equals to what? Tan theta, which is equals to what? The left hand side. So we were able to prove that first part. That is our part 1. Stay more for our part 2 of proving of our identity, up until we do the most trick example of and also applying this into the trickiest part of our proving of identities.